Welcome to this episode of Mr. Lehman's Knowledge Explosion. In Unit 5, Lesson 2, I simply want you to know 4 words and their definitions. The first is perpendicular bisector. So I've given these definitions, and I'm going to draw on the picture so you understand what they mean very specifically. A perpendicular bisector is a segment, ray, line, or plane, basically anything that is perpendicular to a segment at its midpoint. Well, that gives you lots of information, because if it's perpendicular, that means it's going to make a 90-degree angle. And if it's hitting the midpoint, it's going to cut that segment into 2 congruent pieces. So in this triangle, if I give you AX as a perpendicular bisector, then you know BX is the same as CX, and you know that AX is making a right angle with segment BC. Now what you need to understand is you don't need a triangle to do this. If I give you any segment, and I say you have a perpendicular bisector, that means you get a right angle and 2 congruent segments. But you'll notice that the perpendicular bisector itself is not necessarily cut in half. It's just cutting that segment in half while it hits at a 90 degree. Now an angle bisector does something very similar, but it's going to bisect the angle or cut the angle in half. So in the example, AX is an angle bisector, meaning that that angle A is being cut into 2 congruent pieces. Notice that it in no way affects the opposite side. And what I'd like for you to do is draw a more random triangle to get a feel for what this looks like. Because if I cut this angle in half so that the top angle is 2 congruent pieces, you'll notice that the bottom 2 sides do not look like they're the same, and I in no way get a right angle where that angle bisector hits the base. So it simply cuts the angle in half, nothing more. A median is a segment that must be in a triangle, keyword, it has to be in a triangle, where it's drawn from a vertex in the triangle to the midpoint of the opposite side. So in your example, when it says AX is a median, I know that A being drawn to X is a midpoint at X, so BX and CX will be the same. It looks perpendicular, but a median does not mean anything about perpendicular. It would happen in an isosceles triangle like we've talked about, but again, I want you to draw a second example of a less familiar triangle. A median simply goes from the vertex to the midpoint of the opposite side. So I will get that base cut in half, but I don't necessarily get a right angle. I don't know if the angle at the top gets cut in half. I only know that it was drawn to the midpoint, period. Altitude we mentioned before, another name for altitude would be height. And altitude is simply a perpendicular segment from a vertex to the opposite side. So it's very similar to a median, except I get the right angle without getting the 2 congruent segments at the bottom. So again, when I go to draw a random triangle, the altitude has to start at a vertex and go to the opposite side and make a 90 degree. Clearly that's not hitting the midpoint of the opposite side, but it's still making a 90 degree angle. That's all you get from those definitions. So try and understand them, draw the examples, make sure you get them drawn correctly. Now the other words I want you to understand are things like circumcenter, incenter, centroid, and orthocenter. These are very special points. So I'm going to draw 2 of them for you. The circumcenter, for example, is when you draw a triangle and you draw all 3 of the perpendicular bisectors. So I will draw the perpendicular bisector of this first point, of this first side. Now, notice that it didn't go through the vertex of the triangle. A perpendicular bisector does not. Medians and altitudes do. So when I draw the second perpendicular bisector, again, it simply has to go through the midpoint of that segment and be 90 degrees. And then I will draw the third perpendicular bisector, which has to go through the midpoint, and it has to be 90 degrees. You'll notice that when I drew all 3 of those perpendicular bisectors, they all seem to hit at this very one specific point. That specific point is what we refer to as the circumcenter. And there's a couple theorems that I'm going to discuss with you that go along with that. In-center would be the same point where all the angle bisectors meet. The centroid would be the point where all the medians meet. So let's draw that one out as well. Again, I'm going to draw a random triangle, and I'm simply going to draw the medians. So median goes from the vertex to the midpoint of the other side. So that one does have to start at the vertex, cuts that base in half. The other median would have to go from the opposite vertex to the midpoint, so it's going to cut that segment in half. And then the last one has to go from the opposite vertex to the midpoint on the opposite side. And you'll notice right here again in the middle, all three of those medians hit at one very specific point, and we call that point the centroid. So when you see those words, refer back to this and understand what those are referring to. Turn the page, let's look at the theorems that I want to discuss. The first one says that if a point is on the perpendicular bisector of a segment, that it is equidistant from the endpoints of the segment. Well, equidistant sounds like what it means. It's equal distances from those endpoints. We've talked about this a little bit. We've said that if you have a perpendicular bisector, we know that that's going to hit the midpoint and be perpendicular, that this point up at the top, point D, is going to be the same distance to those endpoints A and B, which we've known because of the isosceles triangle theorem for a long time. So it's basically another way of saying that if you're on the perpendicular bisector, so you have a perpendicular segment and it hits the midpoint, the two segments on that triangle have to be congruent if the vertex is on the perpendicular bisector. So in an isosceles triangle only, an altitude is a median, and it is an angle bisector, and it is a perpendicular bisector, only if that triangle is isosceles. The second theorem I want to discuss is the three perpendicular bisectors meet in a point called the circumcenter. That circumcenter is equidistant from the vertices of the triangle. So you notice in this first example, I've drawn the three perpendicular bisectors using my geometer sketch pad. So this is a perfect 90-degree cutting segment AB in half, as is this segment, as is this segment. So these are all perpendicular bisectors, and they meet at this point right here, the circumcenter. That circumcenter is the same distance to vertex A, vertex B, and vertex D in that triangle. And that's a very useful theorem sometimes. It's equidistant to those vertices. Now what I don't want you to think is that circumcenter always has to be in the center of the triangle and that the perpendicular bisector goes through the vertices. It doesn't have to. Again, this point right here is the circumcenter, and it is the same distance to this vertex as it is to this vertex as it is to the third vertex. That's what this theorem is saying. The circumcenter will be equidistant to all three vertices of a triangle. And the last theorem I want you to be aware of is the one that says the median of a triangle is divided by the centroid. In fact, the centroid of a triangle divides the median into two segments whose ratio is 2 to 1. The segment that goes from the vertex down to the centroid will always be twice as big as the segment that goes from the centroid to the midpoint in a ratio of 2 to 1. So you notice on this diagram, I use my geometer software program, and from C to D is 7, and from C to E is exactly 3.5, exactly half as long as it was from the vertex to the centroid. So we can use that to find lengths of segments in triangles and find angles and do some things. So see if you can use these theorems starting on the next page to answer the true-false questions, and then see if you can use them to answer the questions in this section. If you have trouble, look at the answers and check your work, and then see me with any questions.